Next, we're going to take a look at long division and synthetic division before we get started on section 5.2. So this should be a little bit of a refresher. So long division is when you divide numbers by hand in order to get a remainder. For example, 2 does not divide 9 evenly to get a whole number. There's always going to be a remainder of 1. You divide the dividend by the divisor to find your quotient and your remainder. And this might seem like, why are you reminding me of this? We learned this in like 2nd, 3rd, or 4th grade. Well, I want to show you a couple examples of how to use long division with whole numbers before we move into using long division with polynomials, because they tend to follow the very similar steps. So for example, if I have 19 divided by 3, I say, okay, how many times does 3 go into 1? Well, it doesn't. So I look at both terms and I say, okay, how many times does 3 go into 19? Well, that's going to be 6. 6 times 3 is 18. I subtract this row and I get 1. So I get 6 is my quotient with a remainder of 1 out of 3. So this would be 6 1/3. If you were to punch this into your calculator, you'd get 6.3333, on and on and on forever. Let's take a look at 674 divided by 5. I look at my first term and I say, okay, how many times does 5 go into 6? The answer is 1. 1 times 5 is 5. I subtract that. I get 1. And I pull down my next term. Okay, how many times does 5 go into 17? Well, 5 goes into 17 3 times. 3 times 5 is 15. I subtract 15 and I get 2, and I pull down 4. Okay, how many times does 5 go into 24? The answer is 4. 4 times 5 is 20. I subtract that, and I get a remainder of 4. So I would have 134 and 4 fifths as my answer. Dividing a polynomial by a binomial works the same way. What you have to do is first you have to arrange the terms of both dividend and the divisor from highest power to smallest power. Then you want to divide the first term by the second term, the first term in the divisor by the first term in the dividend. The result's going to be the first term of our quotient, okay? What then we do is we're going to multiply every term in our divisor by that term we just found for our quotient. What we do is we subtract that product from our dividend and bring down the next term, just like we did for when dividing whole numbers. We have to repeat this process, right, until our remainder can no longer be divided, okay? And this will occur when the degree of our remainder is less than the degree of our divisor. So let's go ahead and open up a new space so I can work through this problem. So we're going to take x squared minus 17x plus 74 divided by x minus 5. So I have x minus 5, and we're going to use that to divide x squared minus 7x plus 74. Okay, so I look at x squared and I think, okay, what can I multiply x by to make it look like x squared? The answer is x. X times x gives me x squared. X times negative 5 gives me a negative 5x. But then I subtract this row. Note, I'm putting it in parentheses because I need to distribute that negative. My first term's always going to cancel out. If it doesn't, I made a mistake, and that's okay. We can fix it. I have negative 7x minus a negative 5x, so it's plus 5x, so I get negative 2x, and I pull down my next term of 74. Now I looked at my new remainder, and I say, okay, what do I multiply x by to make it look like negative 2x? Well, that's going to be a negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 5 is a positive 10. I subtract this row. My first term cancels. 74 minus 10 is 64. So I'm left with a remainder of x minus 2 plus what our remainder was over our divisor. These are not perfect factors because there is a remainder. Here's an example of polynomial long division worked out step by step in a lovely picture for you to use as a reference. So let's take 2x squared plus x minus 10 divided by x minus 2. And let me switch back to blue. I think that's easier to see on this white screen. So I look at my first term and I say, okay, what do I multiply x by to make it look like 2x squared? The answer is going to be 2x. 2x times x is 2x squared. 2x times negative 2 is a negative 4x. I then go ahead and subtract. My first terms cancel. X minus a negative 4x, that's x plus 4x, so I get 5x, and I pull down my next term. Now I think, okay, what do I multiply x by to make it look like 5x? Well, that answer is 5. 5 times x is 5x. 5 times negative 2 is negative 10. I subtract these and I get a remainder of 0. Okay, so that means that these are perfect factors. I can rewrite 2x squared plus x minus 10 as x minus 2 times 2x plus 5 because the remainder was 0. And you see if I FOIL these back out, I'm going to get back to our original polynomial. That's what we want to be able to do. So these are factors. I factored that degree 2 polynomial, which you guys could have probably already done using one of our many factoring methods. Okay, now I have 7x minus 9 minus 4x squared plus 4x cubed, all divided by 2x plus 1. Now this should make you feel kind of cringy, that numerator, like ugh. And the reason is because our polynomial is not arranged in descending power of terms. So we got to rewrite this guy. Now we are ready to divide. I say, okay, what do I multiply 2x by to make it look like 4x cubed? The answer is 2x squared. 2x squared times 2x gives me 4x cubed. 2x squared times negative 1 gives me a negative 2x squared. I subtract, my first term cancels. A negative 4x plus 2x becomes negative 2x squared, and I pull down my second term. Okay, what do I multiply 2x by to make it look like negative 2x squared? The answer is going to be negative x. Negative x times negative 2x gives me a negative 2x squared. Negative x times negative x gives me a positive x. I subtract. 7x minus x is 6x. I pull down my next term. What do I multiply 2x by to make it look like 6x? The answer is 3. 3 times 2x is 6x. 3 times negative 1 is negative 3. I subtract. I get a remainder of 6. So I have 2x squared minus x plus 3 plus 6 out of 2x minus 1. So 2x minus 1 is not a perfect factor of this degree 3 polynomial because there's a remainder. Last but not least, something I want to point out, if I've got x cubed minus 1 and I'm dividing it by 2x minus 1, okay, one thing that I have to do is I have to put in placeholders for each power of our variable that I'm missing. So if I have 8x cubed and divided by minus 1 divided by 2x minus 1, I say, okay, what do I multiply 2x by to make it look like 8x cubed? The answer is going to be 4x squared. 4x squared times 2x gives me a 8x cubed. 4x squared times negative 1 gives me a negative 4x squared. I subtract that. Two negatives make a positive. My first terms cancel. 4x squared. I pull down my next term. What do I multiply 2x by to make it look like 4x squared? The answer is 2x. 2x times 2x is 4x squared. 2x times negative 1 is a negative 2x. I go ahead and subtract. My first terms cancel. 0 minus a negative 2x is like plus 2x. I go ahead and pull down a factor of my next term. What do I multiply 2x by to make it look like 2x? The answer is going to be 1. 1 times 2x is 2x. 1 times negative 1 is negative 1. I subtract these and I get a remainder of 0. So 2x minus 1 was a factor of our original polynomial. So I could rewrite 8x cubed minus 1 equals 2x minus 1 times 4x squared plus 2x plus 1. What we're going to learn in the future sections is that we want to continue to keep factoring. So next I would need to factor this degree 2 polynomial until I've got a whole bunch of degree 1 polynomials.